This video, we're going to talk a little bit about work and energy, um, what they are, how to calculate work, and how it relates to energy too. So a definition of work is a force times the distance. So if we're doing work on an object, so work equals a force times how far it's moved. So a force times the distance. And if you remember, we talked about force before, that force equals a mass times its acceleration, all right? So work equals a force moved over a distance. So let's say I have a box here. I have a box that has a mass, or has a force of 10 newtons. Okay, and I need to lift it up some stairs. So I lifted up some stairs, and my stairs are a total of 3 meters. So I would do this. So I would say, okay, work equals force times distance. So work equals a force of 10 newtons times a distance of 3 meters. So therefore my work equals 30, right? So 3 times 10 is 30, and it's a Newton times a meter, or we do the unit what's called a joule. So this is the units for work. Units for work is a joule, which we abbreviated as a capital J. Okay, and it's the same thing as a Newton times a meter, or a force times a distance. That's what a joule is. Okay, and so that's what work is, and how we define work. So work is just a force times the distance. Now, when we talk about energy, let's do some units of energy. So we're going to talk about energy where there's different forms of energy. Let's do a couple of basic ones. First of all, we do what's called potential energy. So potential energy. So potential energy is stored energy. There are several different types of stored energy. So let's say that I'm right here. I'm holding a block right here. It's above the ground right here. So if I was to let that block go, it would fall to the ground. So in other words, right now it has potential energy because it has stored energy. It can be converted into something else. If I have, let's say I have a log right here, and I want to build myself a fire. So this log has stored chemical energy. I light it on fire and it starts to burn. Okay, so that's another example of what we would call potential energy. If I'm shooting my bow, so I've got my bow here, I got my arrow. Okay, this in the limbs right here of the bow, there's actually stored potential energy in the limbs of this bow right here. Because if I let it go, that arrow is going to fly off right here. So it has the ability to do work, or it has stored energy. That's what we call potential energy. Okay. The next one is called kinetic energy. And kinetic energy is energy in motion. So it is moving. So anytime something is moving, it has kinetic energy. So here, if we have a car driving down the road, it has kinetic energy. Okay, if I'm running, so if I'm running, I'm moving, then I have kinetic energy. Okay, now we can also take this smaller to the molecular level, where we have in the air, we've got molecules that are moving, right? And they have kinetic energy. And the faster these particles move, the hotter the temperature is. Okay, so kinetic energy is just energy in motion. Now, we do something called the law of conservation of energy. So the law of conservation of energy. Okay. Now let's go back to our burning log up here. So let's say we have our log right here. Okay, it's on fire. Okay, and then when we're all done, we're going to have a pile of ashes here. All right. Well, all this potential energy in this log. Where did it go? Well, it got converted. So all that potential chemical energy, so the potential chemical energy was converted to heat. Okay, so now all this fires, this is giving off heat, and it also gives off some light. So we could have some heat energy and some light energy. It could be converted from one to another. Now, Albert Einstein talked about this. He said that E equals mc squared. So he said that energy equals mass times the speed of light. Okay? So energy, the energy contained in an object is equal to its mass times the speed of light squared. That's E equals mc squared. Now, what does work have to do with energy? Okay, so we talked about work is force times distance. Well, we talk about kinetic energy. Kinetic energy is the amount of work done on an object. So the amount of work done on an object. So how much energy do I have? Well, if I'm running, it is the amount of work that I do is being converted to kinetic energy. So that would be an energy or what kinetic energy is the amount of work done on an object. So this is just a little preview about work and energy and how it relates together.